Alright, here we go. Exercise 10B. The reason why I left it to last is just because it's, some of you might have done physics, then acceleration, velocity, and speed, that might make sense. Some of you haven't, and because it's new terminology, it's only the one part. It's called kinematics, and you can apply that with 10F, 10G, and I felt that C, D, E is more important because that's stationary points, and that's powerful. Whereas kinematics, sometimes you get a particle with a velocity, speed, whatnot, then you use it. So that's why it's a smaller part, and it's easier to get if you've understood everything I've talked about. Derivative is a gradient, and you understand that the stationary point is when the gradient's 0, tangent line, normal line. If that all makes sense, this is easy, super easy. Okay, so let's have a look. Average rate of change versus instantaneous rate of change. I talked about this in chapter 9, but I'm just going to remind you again. Average rate of change is the gradient of a line between 2 points. Hence why it's average, because between 2 points, what's the average change? That's what you're saying, like as x increases and y increases or decreases, what is the change? And that's why it's between 2 points. Whereas instantaneous rate of change is the gradient of a tangent line at a particular point. Now that is what you've been doing when you're finding the gradient by differentiating at a point. Remember how I keep telling you to find the tangent at a certain point? What you're actually doing is you're finding the instantaneous rate of change. So just to remind you, let's say I gave you y equals x squared, and you know the derivative is dy dx, which is 2x. But if I asked you, find the equation of the tangent line, so y equals mx plus c, at, I don't know, let's say at x equals 2, and that line passes through, I don't know, let's say 0, 5. Okay? Then what you would have done in 10A, 10C, 10D, 10E is to find the equation of the tangent line, you say the gradient is dy dx at x equals 2. That right there is the definition of instantaneous rate of change, because you're finding the gradient, which is the derivative, at a point. Derivative at a point tells you the gradient of your tangent line. And that's key because when you're talking about speed, velocity, and acceleration, or distance, velocity, or displacement, velocity, and acceleration, this concept is repeated. That's why 10B is after 10A. 10A is about tangent lines, and you're going to use tangent lines to get your head around kinematics. Okay? So, here we go. Let's look at today's definition. So, derivative at a point, which really is just finding the gradient of your tangent line. Keep that in mind. Gradient of a tangent line, yeah, at a particular point. So, let's have a look at a couple of questions, and these are sometimes comes up in your multiple choice section. Average rate and instantaneous rate. Those are the only two that I think students normally get confused between. Average rate of change is literally y2 minus y1 divided by x2 minus x1, because it's just your gradient. That's what you've been doing in year 9. That's been the average rate. We've just given a name to it. Okay? So when you're finding the gradient and it says from 2 to 3, that's 2 points. So your x value is at 2, and your x value is at 3. You just need to find out your y values. And how do you find out your y values? What do you do? Yeah, you sub them in. Because the equation tells you here. That's your y value. Y equals to whatever x is squared plus 2x. So here, I would have 2 squared plus 2 times 2. And here, I would have 3 squared plus 2 times 3, which works out to be 4 plus 4, which is 8. And that is 6 plus 9, which is 15. So far, I've got x1, y1, x2, y2. So when the first question says find the average rate of change, the average rate of change is really, well, I should just use avg. Average is equal to y2 minus y1 over x2 minus x1, because you're just looking what's the overall change, what's the average. Okay? So the average would then be, I don't know, let's say 15 minus 8, and then you got 3 minus 2. That gives you 7 on 1, gradient of 7. Okay, so that's my average rate of change. It just means for every one across, I'm going up by 7. That's what it tells me. Yeah? And then average rate of change for the interval 2 to 2 plus h, exactly the same thing. The only thing I'm changing is that. Okay, so that becomes 2 plus h squared plus 2 times 2 plus h. And that's pretty much your first principles. See, when you did your first principles, it was f of x plus h minus f of x divided by x minus x plus h divided by minus x. Yeah? That's just the first principles. Now what's c? C is different because it's instantaneous rate. So you only find the gradient at one point. Now you can't find the gradient of one point. The only way to do that was first principles, where limit of h approaches 0. That's why you can find out the derivative at one point. Every time you had to find a gradient back in year 9 was you needed 2 coordinates. Now you only need 1. So the only way to do that was finding the derivative at x equals 2. So the derivative dy dx, or technically is actually f dash of x, is equal to 2x plus 2. That's my derivative, but I want to know what the gradient, what my rate of change is, what my instantaneous rate of change is at 2. So at f dash of 2, that equals to 2 times 2 plus 2, 4 plus 2 is 6. And what that is it tells me the rate of change at that particular point is for every one across, it's 6 up. This one on average between 2 to 3 is every one across, it's 7 up. This is just a gradient, rise over run, 7 over 1, 6 over 1. Does that make sense between the difference between average rate and instantaneous? Hands up if you get it. Very good, excellent. Okay, now we're going to go into terminologies, okay? So this is just your basic questions, and you'll probably get that type of question in an exam as a multiple choice, just one. So it's always easy, easy 1 mark, okay? Now, this is where kinematics come in terms of terminologies. Those who've done physics, this would make a lot of sense. For those who haven't, you're going to have to try to get your head around this. Very simple concept. Here we go. Velocity and acceleration. You also have what we call displacement, which we call it x. Okay? Displacement, velocity, acceleration. The difference between this, versus what you're used to back in junior level was distance, speed, and you don't have acceleration. Okay? Distance and speed does not have a direction. If you see speed, you just say 60 kilometers per hour, you're just telling me a value, it's a magnitude, it's a scalar value. Distance is also a scalar value. Whereas displacement, velocity, and acceleration, they all have a direction. That's why you have a positive and a negative, and that's why it's useful for us when it comes to gradients, because gradients have positive gradient, negative gradient. Distance, speed doesn't. But you can still work out distance and speed from your velocity displacement. Okay, so a quick example of what I mean is, let's say this is your particle. Okay? Let's say this is your timeline. Let's say this is 0 distance. That's where they're starting at, origin. Let's say I told you that it moved across 3 units to the right. 3 units to the right. And then the particle bounced off and decided to travel backwards. And it traveled all the way 3 units left from the origin. Okay? What you would tell me displacement is more about where are you relative to where you started. That's what displacement is. Okay, so it's sort of like I'm here, this is where I start. So I took a step to the right and I took a step back. Relative to the origin, I haven't moved. But how many steps have I taken? 2. So that's called distance. Distance is 2. Displacement is 0. So displacement, the other word for it is position. Okay, so position, where you are relative to where you started. So in terms of position, I am 3 to the left of the origin. But distance, I've gone 3 to the right, 3 back, and 3 across. So that's 3 plus 3 plus 3. I've actually moved 9 units in total. So the difference between distance and displacement, distance tells me I've moved 9 units. Displacement tells me I've moved -3. See, the negative is a direction. See the difference between displacement and distance? Distance does not have a direction. You either start at 0 or you move somewhere, and you calculate the total. Displacement tells me a direction. So now I know from where I started, I'm 3 to the left of where I started. That's what the negative implies. Okay, positive implies I moved to the right by 3. Same thing with your velocity. Velocity now is the measure of how far you have displaced yourself over time. Okay? Whereas speed is how far you've traveled over time. See that difference there? So one's talking about position, change of position in relative or in relation to time. Speed is change in distance over the change in time. That's the difference between the two. So if I write it out as notes, speed is change in, and that symbol there means change in distance over change in time. Whereas technically that's average speed because you're changing. That means y2 minus y1, x2 minus x1, or d1 take away d2, t1 take away d2. Yeah? Average speed is change of distance over change in time, whereas velocity is average change in displacement or position, change in position over change in time. That's the difference. Why don't we have acceleration when it comes to speed? Because acceleration is the measure of how fast you change your direction or position. So that's where your acceleration is, and that's why it's in relation to velocity. Okay, now the nice thing is if acceleration is described as how fast velocity changes, then that's dv, which is change in velocity over change in time. This is all derivatives. The derivative of a velocity function gives you the acceleration. Derivative of the displacement function gives you the velocity. Okay, and I'll do an example so you see what I mean. But the idea is displacement is position. How fast you move from position to position is called velocity. How fast you move how fast you are is called acceleration. So how fast is it so that you can, I don't want to use the word accelerate because it sounds like it's confusing you. It's how fast is your speed. Okay, how fast is your velocity is acceleration. Okay, how do we feel with that so far? Like the main thing I want you to take out of this is the difference between average speed, average velocity. One talks about position, one talks about distance. That's what I want you to take out of it. Okay, because a lot of times when I give them these kind of questions, students confuse between these two. And both of them are totally different. One talks about distance, one talks about position. So for example, this one, if I told you the time, if it was like 9 seconds in total, then my average speed would be 9 divided by 9. Whereas if it's my displacement, it will be -3 divided by 9. So velocity and speed will have a different value. Okay? All right, let's have a look at an example just to tie things together, okay? Here we go. Let's look at this example. So a particle moves along a straight line, so I know it moves along a straight line, such that its position, so that's a key word there, position means displacement. Okay, so x represents your displacement relative to a point O. So let's say this is your O, origin, so it's relative to the origin. At time t seconds, so it's in seconds, is given by the formula. So this is a displacement formula. This is to calculate the displacement, the position where you've moved. Okay, so as time increases, this will tell you which position you're at. Okay, so this is a position graph. X equals to t cubed minus 6t squared plus 9t. Right? First question says, at what times and in what positions the particle will have 0 velocity? Okay, so 0 velocity. Velocity is determined by the change in your position over change in time. So what they're asking is, if v equals 0, what is x equal to, and what is t equal to? Whoops. Because that's what they're asking. They're saying, what times, so what is t? Position is x, so what is x if 0 velocity? So that's what they're telling you. They say v equals 0, find x, find t, right? You've got a position equation. Now to find v, we know that it is the change in position over change in time, which is actually the derivative. The derivative is actually the change. That's what your gradient means. Gradient means change of one variable over another variable. In our case, it's position, time. What you're used to in year 9 was y, x. Change of y over change in x. You called that the gradient. We now call it the derivative. Then the same thing, the derivative of your position time graph is your velocity. Okay, so here we go. So if I now want to find and answer this question, A, I say V is equal to dx dt. Let's find the derivative. What's the derivative of t cubed minus 6t squared plus 9t? What's that equal to? Let's go. Josh? Good. Okay, so this is my quadratic equation. That tells me my velocity. And I want velocity to equal to 0. So when v equals 0, you have 0 equals 3t squared minus 12t plus 9. Your question was find t, find x. Now according to this equation, I'm likely that I'm going to solve for t. So let's solve for t then. Let's see when will I have a velocity of 0. Okay, so let's solve for t. I can divide them all by 3, so that makes it t squared minus 4t plus 3. Factorize that, because it's quadratics. T, 3, 1, negative 3, negative 1. So, this tells me now, using null factor law, t equals 1, or t equals 3 seconds. Now what I want you to understand is, what does this mean? So one thing I've taught you is method. But you have to question, what does this mean in relation to the question? So the question says a particle is moving in a straight line. What does it mean when we say velocity 0? How is it possible to have velocity 0? It just means you've stopped. That's the only time you're going to have 0 velocity, because if you move, you stopped. So that means at 1 second, the particle stopped, and at 3 seconds, the particle stopped. What I don't know right now is which direction it's going. Okay, so all I know is 1 second, it stopped, 3 seconds, it stopped. So the question asks you to do, find what positions. So the only way to find a position is right here. They said, if you know what your time is, I'll tell you what your position is. You know time is at 1, time is at 3. Now you can tell where the position is. So let's work this out. At t equals 1, x equals to 1 cubed minus 6 times 1. What's going on over there? What's that? 3 plus 1 equals 4. So what's this positive 4 tell me? That's 4 units positive from the origin. Whereas t equals to 3, you have x equals to 3 cubed minus 6 times 3 squared plus 9 times 3. 27 minus, what's that, 54 plus 27. I'm not really good, that's 0 actually. Is that right? Did I do it right? Yeah? So if it's 0, what does that imply? It means my position is exactly where I started. Now what I want you to do is picture this. Picture the whole scenario, because kinematics is only hard if you don't picture what's going on here. So let's picture it. I'm going to draw it in blue. You start at origin. Apparently after 1 second, you're 4 units or 4 position away from the origin. So 4's over here, that's 1 second. So 1 second, you're now over here. So it's moved here. It's gone there. And it stopped because velocity is 0. Then, for the next 2 seconds, so from 1 second to the next 2 seconds, where's my position? 0. So that implies that I've come back and I've stopped here. And that's a total of 3 seconds in total, but I've actually had an extra 2 seconds there. So t equals 3 at this point. Now why is that key? Because the position, I actually ended up at the origin. But distance, see, I've actually moved 4 units to the right and then I went 4 units back in the next 3 seconds. So that means the total distance, I've moved 8 units. Displacement, I haven't moved at all. So in the first 3 seconds from 1 to 3, I haven't moved at all. Okay? So answering the next question, it says it's acceleration at those instants. Acceleration is the derivative of your velocity. But what I'm drawing up here is for you to picture it. Because the reason why is when they, in the next few questions that you work with, they're going to get you to calculate the missing length, because they'll tell you the total distance, and then you work out from one point to the other, and you have to minus them to find out your missing lengths, or missing time, or average speed or average velocity. You have to work out your distance to work out your average speed. Yeah? That's the only part that's hard. But what are you taking out of this exercise? Velocity is the derivative of your displacement. Acceleration is the derivative of your velocity. And finally, speed is the derivative of distance, or change in distance over change in time. That's the difference. So there's only 4 things that you had to take out of it. And if you read the question properly, you just answer as it goes. So the next one is derive your velocity function. So this is my velocity function. Derive this and you get b. Okay, so it's acceleration at those instants. Now those instants are 1 and 3. So what they're asking you to do is find dv dt at x equals 1 and at x equals 3. That's what B is asking. And then finally C, it's velocity when its acceleration is 0. You're going to find out when acceleration is equal to 0, find out the time, and you can sub it in to find velocity. Is this sort of feeling like it's making sense? Yes? Yeah? All right. Let's try this. I'm going to pick, I'm just going to pick one question, and I'm going to get you to work on this. And if it makes sense, we're moving on. Okay, we're moving on to 10F, and we'll tie it all together. But I'm thinking, which one was a good one? No, I'm looking for one with speed. Hey, there's no speed. Where's the speed question? Huh, no speed. All right, just do question 11. Go to question 11, check your answers, and then we'll move on to the next part, which is 10F. Okay, so just a quick reminder. Speed equals change in distance over change in time. Velocity is change in displacement over change in time. Acceleration is a change in velocity over change in time. And X is displacement, which means position. Those are the 4 things you had to understand. All right, have a go with question 11. And then we'll move to 10F. And then we only have one more exercise before we finish chapter 10. Let's have a go with 11. Distance, displacement, velocity, acceleration. Understand what those terms mean? Have a go with these questions.
There's already a